Hello and welcome to another video of Learn with Christian. So today we'll be learning about theoretical analysis of Cadell cycle. The calculation of the Cadell cycle may be a little burdensome, but it may prove useful to practicing engineer who may be interested in performing a heat and mass balance around cryogenic systems should an operating problem occurs. Following 2.6 and assuming that the expansion engine is reversible and adiabatic, the expansion process is isentropic. In this manner, a much lower temperature is achieved than an isenthalpic expansion as practiced by Linden. In the Cadell cycle, air and feed gas is compressed to approximately 40 bar and passed through a primary heat exchanger. About 75% of the feed is diverted, expanded and returned reunited with the cold vaporized gas from the liquid being produced. The combined stream are then recycled and passed through an ultimate expansion valve for total liquefaction. The use of expansion valve is still necessary to avoid the formation of liquid in the cylinder of reciprocating expansion machine. In reviewing the TS diagram and applying the first law of steady state flow through the heat exchanger, expansion valve and liquid containers as a single unit with no heat transfer. So this is the figure. Let's now go to this example numeric. Cadell cycle with pre-cooling. The Cadell cycle can also be improved by adding a mechanical refrigeration unit immediately after the main air is compressed. Correct. The calculations are the same as previously noted but are lowered by dropping the process air temperature to say 278 Kelvin. In fact, all designers of present day air separation plant use pre-cooling as a standard practice. Yes, so pre-cooling is like if it can be done, it should be done, okay? Because for the price sense of view, I think it makes more of a sense. Cadell with dual pressure. Okay, so let's learn this. The basic dual pressure cycle is similar in the principle to the dual pressure Linden's process, but in the Cadell cycle, only the portion of the stream entering the expander is compressed to a high pressure, which reduces the energy consumption considerably. Using nitrogen as the refrigerant, the main process feed is compressed from 101.3 to 1013 kilopascal 10 bar. Approximately 60% is cooled to 160 Kelvin and sent to the expander. The remainder 40% is further compressed to 3530 kilopascal 35 bar, cooled and undergoes a Joule to temperature expansion through a throttle valve to 101.3 kilopascal atmospheric level. Okay, so from here compressor, then here after cooler purification is done to the main exchanger, from where expansion engine takes over an expansion valve. From here another thing, and from here the air is taken to rectification section, from where gases, oxygen and nitrogen is taken out. So gases is taken out, but liquid nitrogen, liquid oxygen is taken out like this. Lovely. This is more of a Cadell deer. Makeup gas and all this. Okay. Carnot cycle with high pre-cooling to liquefy hydrogen or neon. Oh my god, so to liquefy the hydrogen is, I think, a bigger task. Okay, so the Carnot cycle may be used to liquefy hydrogen or neon without modification by using liquid nitrogen pre-cooling 2.9 and assuming the following operating conditions. So one is para hydrogen. There are three types of hydrogen to my knowledge, but yeah, you check that out. Okay, so para hydrogen, meta, para and ortho, I think they are those, but I'm not sorry. Okay, so para hydrogen compressed to 0.01 kg per second for liquefier and refrigerator. So temperature of all stream on the one side of the 3-channel heat exchangers are at 293 Kelvin. Compressor operates between 1.01 and 10.1 bar. Initial temperature to expander is 60.8 Kelvin. 70% of the para hydrogen diverted through the expander. Assume ideality from the expander, compressor and heat exchanger. The liquid nitrogen bath operates at a pressure of 1.01 bar. So this is it. So yeah, so we'll do this Capita cycle in next class. The Carnot process cycle using nitrogen as a pre-coolant may also be used as a low temperature refrigerator by using the vaporization of liquid produced. Okay, thank you for watching. See you another video. Take care. Bye bye.